Ever tapped your screen and instantly watched a video load? Or clicked send on a message and it reached someone thousands of miles away in just milliseconds? But how? What if I told you that beneath every swipe and scroll lies a hidden world of servers, satellites, cables stretching beneath oceans, and machines talking in a language only they understand? This isn't science fiction. This is the internet. And today we're going to peel back the digital curtain and reveal what really happens when you go online. Stay with me, because once you know the truth, you'll never look at your Wi-Fi the same way again. Hello, my curious fellows. Today we learn about what is the internet, really? Most people imagine it as something floating in the air, like a cloud. But the truth is far more fascinating. The internet isn't a single thing or place. It's a massive, interconnected network of smaller networks, millions of computers, servers, smartphones, routers, and devices all talking to each other. Think of it like the digital nervous system of the modern world. When you send a message, stream a movie, or search on Google, your device sends out a signal. That signal travels across invisible highways of data, bouncing through cables, satellites, and servers until it reaches the right destination and comes back to you in a flash. But none of this would work without a shared language, called protocols. The most important one is TCP/IP, Transmission Control Protocol and Internet Protocol. It's the system that helps devices identify each other through unique IP addresses, break down information into tiny data packets you send and receive those packets, reassemble them into the content you see. It doesn't matter if you're in New York and the server's in Tokyo. Thanks to TCP/IP, your request knows exactly where to go and how to come back accurately and almost instantly. And here's the amazing part. This all happens behind the scenes in mere milliseconds. The internet has no central brain, no master control room. It's decentralized yet perfectly coordinated, a living, breathing system of endless communication. In short, the internet is everywhere and nowhere. A ghost highway built on light, electricity, and code, powering the world we live in today. The internet didn't appear overnight. It was born out of tension, secrecy, and a need to survive. In 1969, during the Cold War, the U.S. Department of Defense launched ARPANET, a top-secret experiment to build a communication system that could withstand a nuclear attack. That same year, the first digital message was sent from UCLA to Stanford. It was meant to say login. But just two letters, L and O, got through before the system crashed. That simple glitch marked the birth of the internet. Then came the milestones. 1971, the first email is sent. In 1984, DNS, Domain Name System, is introduced, making websites easier to find. In 1991, the World Wide Web is born, thanks to Tim Berners-Lee. 1998, Google launches and changes how we search forever. 2000s, social media platforms explode across the globe. Fast forward to today, more than 4.5 billion users are online, visiting over 1.8 billion websites. But while we use it every day, one question remains. How does it all actually work? All right, let's break it down. Imagine you want to visit a website, say www.example.com. Seems simple, right? But behind the scenes, a digital chain reaction begins the moment you hit enter. First, your device sends a request to your ISP, your internet service provider. Think of your ISP as the gatekeeper to the web. Your ISP doesn't know where example.com lives, so it turns to a DNS server, short for Domain Name System. This is like the internet's phone book. It asks, hey, what's the IP address for this website? Every website lives at a unique address, like a digital home. The DNS responds with the IP, maybe something like 93.184.216.34. Once your browser has that address, it sends a message to the web server where the site is hosted. But here's the twist, that information doesn't travel as one giant file. The website's content, images, text, code, is broken into tiny digital pieces called packets. Each packet carries a chunk of data, along with labels telling it where it came from, where it's going, and how to reassemble itself once it arrives. These packets take off, some through fiber optic cables, others bouncing between radio towers, satellites, or undersea cables running across continents. They might not all follow the same route. In fact, one packet could travel through New York while another flies through London. But when they arrive at your device, your browser gets to work, reassembling each packet in the right order, like solving a puzzle at lightning speed. The result? The full website appears, just as you expected. All of this, lookup, request, transmission, reassembly, happens in less than a second. Incredible, isn't it? Now let's go deeper. This entire system runs on a set of protocols, the rules that keep everything organized and flowing smoothly. The Internet Protocol is like a GPS. It finds where the packets need to go. TCP, the Transmission Control Protocol, is like a safety inspector. It checks that every packet arrives, and in the right order. HTTP, the Hypertext Transfer Protocol, makes websites work. It tells the browser how to format and display content. UDP, the User Datagram Protocol, works like a speed courier. It sends data fast for things like gaming or video calls, where missing a packet isn't a big deal. Without these protocols, the internet would just be a mess of meaningless signals, static in the void. But with them, we get a flawless, almost magical experience, where the entire world is just a click away. So, where is the internet? Most people imagine it floating in the air, like magic. But the truth is much more grounded, literally. The internet lives in physical infrastructure. Fiber optic cables, as thin as a strand of hair, run beneath our streets and even under oceans, carrying light-speed data between continents. Massive data centers scattered across the globe store and deliver your favorite websites, videos, and apps. Your routers and switches act like traffic controllers, guiding data packets to their correct destinations. Satellites and cell towers provide wireless access, but only for the final stretch. And that Wi-Fi router in your home? Just the tip of the iceberg. Behind every Google search or YouTube video is a vast, invisible machine built from concrete, cables, metal, and code. Now, how do you connect to this digital giant? There are a few common ways. DSL uses old telephone lines, slow, but still used in some places. A cable offers faster speeds through TV lines. Fiber is ultra-fast, using light to send data with almost no delay. Satellite connects remote areas, but weather can disrupt it. 3G, 4G, and 5G use cell towers for mobile internet, but speed and coverage vary. No matter which method you use, it all flows through your ISP, the internet service provider, your gateway to the global web. So now you know. The internet isn't magic, but it's the closest thing we've ever created. Every search you make, every message you send, every video you stream, travels through a hidden world of underground cables, light pulses, wireless towers, and digital protocols. It's a global system of unimaginable complexity, working silently, in milliseconds, to keep you connected. And the more you understand how it works, the more incredible it becomes. From your pocket to the other side of the planet, data never sleeps. The internet has transformed how we live, learn, love, and lead. And yet, we're only scratching the surface. If you enjoyed this knowledge, don't forget to like, share, and subscribe to the Universal Knower for more fascinating deep dives into the invisible systems shaping our world. Because behind every screen, there's a story waiting to be told.